Alright, so we're going to be looking for how to find the area between a curve and the x-axis. So let's take a look at the formula that's going to guide our problem solving process. So the formula is as follows. The area between a continuous function f of x and the x-axis on an interval AB is given by, so the area is equal to the integral from a to b of f of x dx. So let's say we have a function let's say it's a curve, and we want to look for the area between two values between a and b. So let's say this is a and this is b. Now this the area of this region right here between the function, let's say this function that we just graphed right here is given by y is equal to f of x. This area is the integral, the definite integral expression that we just wrote. Okay? So just remember that the definite integral represents the area between that function and the x-axis. So the instructions are as follows. Find the area between the function and the x-axis on the specified domain and check your answer. Check your answer with a calculator. With a calculator. Okay? Alright, so for question 1, let's say we have the function y equals x squared minus 6x plus 11 from 2 to 5. Let's go ahead and rewrite the formula to guide us. Area is the integral from a to b of f of x dx. Alright, so we know what our function is. The function that we're going to be integrating is x squared minus 6x plus 11. Our a value is 2 and our b value is 5. So when you're integrating, you always go from left to right. So 2 to 5. Alright, let's go ahead and apply this formula to this particular situation that we're dealing with right here. So the area is going to be given by the integral from 2 to 5 of the function x squared minus 6x plus 11 dx. Alright, so we're going to be carrying out term by term integration here. Now let's just do a real quick review of the two rules that we're going to be using here. So remember your power rule. If you're integrating x to the n dx, it's going to be x to the n plus 1 over n plus 1 plus c. And if you're integrating a constant, so if we're integrating a constant, it's going to be ax plus c. Okay? Alright, since we have a definite integral here, we're going to have a positive and negative c, so that will cancel out and it's going to be applicable in this scenario. So let's go ahead and integrate every single term. So we have the integral of x squared is x to the third over 3 minus the integral of 6x is 6x squared over 2 plus the integral of 11 is 11x by applying these rules here. This integral will be evaluated from 2 to 5. Now let's go ahead and simplify the integrand before we evaluate it at the top and bottom limits and subtract. So we simplify, we're going to have x to the third over 3 minus 3x squared plus 11x evaluated from 2 to 5. Alright, let's go ahead and plug in the upper limit. So we're going to have 5 to the third over 3 minus 3 times 5 squared plus 11 times 5. So you evaluate the integrand at the upper limit minus the integrand evaluated at the lower limit. FTC part 1 minus 3 times 2 squared plus 11 times 2. Okay, so we're going to use the order of operations to simplify this. So let's simplify what's in the parentheses first. So we have 5 to the third, 125 over 3 minus 75. 5 squared is 25 times 3, 75 over 1 plus 55 over 1 minus 2 to the third is 8 over 3 minus 2 times 2 is 4 times 3 is 12 over 1 plus 22 over 1. Alright, so let's go ahead and simplify. So we have 125 over 3 minus let's just these whole numbers right here, let me just leave them as whole numbers. I will convert them into fractions in a second. So minus 8 over 3 minus 12. Now since there's a minus here, you multiply by this 12, so this becomes a plus. Plus 12 minus 22. Alright, so let's go ahead and deal with the fractions first. 125 over 3 minus 8. So we subtract that, we have 117 over 3. And then negative 75 plus 55, that's negative 20. So we have negative 20, and then 12 minus 22, that's negative 10. And then we'll combine them together. We have, so that gives us negative 30. Now 117, if you add the digits, you'll find out it's a multiple of 3, which means that 117 can be divided by 3. So 3 goes into 11 3 times. 3 goes into 27 9 times. 39 minus 30 is equal to 9. Alright, so what we're going to do next is we're going to check our work using the calculator. So the expectation is for you to be able to use the calculator to graph the function and evaluate the integral using the graphing menu. Okay, so let's start off by entering the function into the calculator. So let's title this calculator verification. Okay, so let's go ahead and enter the function into the calculator. We have, we're going to press the Y button, okay, to go into the Y graphing window and then clear whatever function you have there. Now we're going to enter f of x. So if we enter f of x, we have x raised to the second power minus 6x plus 11. Enter. Now we're going to graph the function. Okay, so what we're going to do next is we're going to proceed to graph the function. Well, let me also show you how this looks in the TI-89 calculator. Alright, so using the TI-89 titanium, very similar process. You press diamond F1, takes you to the graphing window, and then you just enter the function x raised to the second power minus 6x plus 11. Press enter, and then make sure what's entered into the y1 function is the same as what you desire. Okay, now we're going to graph the function. For the TI-84, that's your graph button right there. You just press it. And then you have the graph of the function. And then for the TI-89, the green option for F3 is your graphing button. So you press diamond F3 to graph the function. Alright, so if your graph do not look the same, you can always zoom standard. So there's your zoom button for the TI-84. So you have the zoom button there. So just zoom 6 so that it looks, you have the standard graphing window. For the TI-89, zoom is option F2. And then just scroll down to 6 or hit the 6 button. And then you have the standard graph. Okay, there are two ways to find the definite integral. You can do it on the home screen or using the graphing window. I will show you how to do that using the graphing window. So what you do for the TI-84, on top of the trace button, the blue option is calculate. Okay, to access that, you press second function, calculate. Now these are the different options you can calculate on the graph. We're looking for the integral or area, that's option 7. So you press 7. The second you press 7, it takes you back to the graph and it will ask you two questions. What are the limits of integration? What are the boundaries, left and right boundaries you want to find the area of underneath the curve? So lower limit for this problem, the lower limit was 2 and the upper limit is 5. So let's go ahead and enter the lower limit. Just press 2 and then x equals 2 is presented. Press enter. It will then ask you for the upper limit. The upper limit is 5. Hit 5, x equals 5 is presented, and then you press enter. And what it does is it calculates the area for you and also gives you a visual representation of what you just calculated. So it tells you that the area is 9. For the TI-89, F5 will give you the option for calculation. So let's go back to the graph here. So if you press F5 and then you look for integrals, option 7, press enter. The same questions present themselves. Lower limit 2, upper limit 5, enter, and then that's the area you just found, which is a value of 9. So let's go ahead and sketch the graph and also indicate what we just found. Alright, so what we have is a quadratic function. Alright, so let's go ahead and just sketch the function. It's nothing perfect, it's just a general representation of what we have. So we have some quadratic function, and what we computed was the integral from 2 to 5. So let's say that's 2 and that's 5. So we're looking for this area right here, the area between the function and the x-axis, so the integral. So the area, which is the integral from 2 to 5 of the function, was equal to 9, and that shows that our answer is correct. Okay, so that's that.